All right, the rest of these missing coordinates and uh, degrees, these all depend on this other triangle here, the 30, 60, 90. Okay, and I'm going to lay it over our unit circle just like we did with the 45, 45, 90. Okay. There we go. That's pretty close. Okay. And now you can see that the y value at this point should be 1/2, and the x value should be the square root of 2, or square root of 3 over 2. Okay, and so let's write that in here. Square root of 3 over 2, and 1/2. Okay. I'm going to go ahead and move this, and then we'll fill in some more. Okay. There we go. Okay. And again, you can see that the angle that was in the triangle there was the 30. And we'll actually fill in a little more here later. We'll actually fill in the radian measure for all these angles as well. Okay, but since our triangles have degrees, I'm doing those first. Okay, but if we go up to this next one, this is actually supposed to be a 60-degree angle. Okay, and if when you see the 60-degree angle up there, it makes it a little harder to imagine a triangle here. And so that's why I've drawn this little arrow. But is what I want you to imagine is if this little arrow is where 60 degrees is, then what should be opposite of it? Well, if I look at the triangle, I'm going to get rid of that there. If I look at this triangle, okay, opposite of the 60 is the square root of 3 over 2. Okay, and so if I go opposite 60, okay, then that would be the height of the triangle, if you could imagine me drawing that in here. Okay, so I'm going to write that in as our height, square root of 3 over 2. All right, and so if that's the case, then this x value must be 1/2, because we're still actually using that 30, 60, 90 triangle here. Oh, it looks like I took my 0 away. Here we go. Okay, so now to fill in the rest of these, we're really just going to count by 30s. So we have 30, we have 60, we have 90. Those are all filled in. But if you add another 30, that'll get you to 120. Add another 30, that'll get you to 150. Okay, and we'll fill in more here in a minute. But now, to fill in these, I like to just go across the unit circle. So, for instance, if I were to just go straight across here, I know that I should be at the exact same height, also known as the y value. So this should still be the square root of 3 over 2. Okay, which means that this should also be 1/2, but because we're to the left of the y-axis, this should be negative 1/2. Okay. And then down here, you could again imagine going straight across. My height should be the same as the one straight across from it. Okay. And that'll mean that this is also the square root of 3 over 2. I just don't want to forget my negative. Okay. And now to fill in this one, we could go down from this point, like that. And so you can see I should have the same x value here, because I went straight down, minus the square root of 3 over 2. And so if that's the case, then this should be 1/2. And because we're below the x-axis, you know that this y value should be negative. Okay. And then we can fill out this next one. And we could go straight across again. And we know that the y value should then be the same. This should be a minus 1/2. This one here should be a square root of 3 over 2. And I know it should be the positive square root of 3 over 2 because we're to the right of the y-axis. Okay. And I just realized I missed these two down here. Okay. Well, let's do those ones. Okay. I'm going to do the one on the right here first. I'm going to draw in a little bit of a dotted line here. I'm going to go up. Okay. So if we go all the way up, okay, you'll see that that'll bring us up to here, to this 1/2 square root of 3 over 2. Okay. So going all the way up like that means that we should have the same x value. Okay. So if we have the same x value, it should be 1/2. Okay. Let me fill that in here. Okay. And then we should have the square root of 3 over 2. And because we're below the x-axis, it should be negative. Okay. And now let's go back across. If we go back across here, okay, we should have the same y value. So minus the square root of 3 over 2. Okay. And then the x value should just be the opposite because we're on the other side of the y-axis. Okay. And now that we have all those filled in, we can finish off our angles. So remember, we were just counting by 30s to do these green ones. So 150 plus 30 is 180, plus another 30 is 210, plus another 30 is 240, and then 270, and then 300. Okay. And then after 300, we'll have 330. And then you'd actually finally have after that 360 if we made the full revolution. Okay. Now, I did leave out the radian measures. Let's go ahead and fill those in. Let's do the blue ones first. Those were the easy ones again. Okay. So if we're at 0 degrees, we're also at 0 radians. Okay. Then if we're at 90 degrees, remember this is pi over 2. A half of a revolution is pi radians. 3/4 is 3 pi over 2. And then we'll move on to the, let's do the 45-degree angles. Okay. So 45 degrees in radians, that is pi over 4, right? Because that would be half of pi over 2. Okay. So let's just count by pi over 4s. Pi over 4 plus pi over 4. Okay. Let me just write that over here. I'm going to erase it, but if you were to add that, you'd get 2 pi over 4, which is just pi over 2, right? Okay. So that got us to the top of the unit circle. Then we could add another one. Oop. We could do pi over 2 plus another pi over 4. Okay. And if you did that, we'd have to get a common denominator. So we'd have 2 pi over 4 plus pi over 4. And we get 3 pi over 4. Okay. And so that's what's actually going to go right here is 3 pi over 4. Okay. And then I'm going to skip doing all that work for the rest of these. So here we go. So if you do 3 pi over 4 and add another pi over 4 to that, you'll get 4 pi over 4, which is pi. Okay. And then if we add another pi over 4, that's going to put us at 5 pi over 4. Okay, so I'm just, again, counting by pi over 4s. Okay, so 5 pi over 4. And then the next one is technically 6 pi over 4, which will reduce to 3 pi over 2. And then we're at 7 pi over 4. Okay. And then if we add another pi over 4, we'll get to 8 pi over 4, which is equal to 2 pi. That's our one full revolution. Make my 7 pi look a little better. There we go. Now we're on to the multiples of pi over 6 or 30 degrees. So 30 degrees is pi over 6 radians. Okay. And we're just going to keep counting by pi over 6's. So the next one would be 2 pi over 6, which reduces to pi over 3. Okay. And if we were to count to the next one, we'd be at 3 pi over 6, okay, which is pi over 2. Okay. Well, we already have that one filled out. So let's move to the next one, 4 pi over 6. That's going to reduce to 2 pi over 3. Okay. And then the next one would be 5 pi over 6. And then the next one would be 6 pi over 6. Okay. And 6 pi over 6 would just be pi. Okay. And on to the next one. The next one should be then 7 pi over 6. And then 8 pi over 6, which is going to reduce to 4 pi over 3. Okay. And again, this one was 8 pi over 6, so the next one would be 9 pi over 6, which reduces to 3 pi over 2. And then after 9 would be 10 pi over 6, which is going to reduce to 5 pi over 3. And then finally 11 pi over 6. Okay. And so we have this all filled out now. Okay. And hopefully going through this all in detail will help you remember how to fill it out. But what I would like you to do is in the next week, remember this unit circle. Okay. And while part of the reason for remembering it is so that you can find sine and cosine easily of these common angles, the other reason is far more important but overlooked. It's that when you memorize this unit circle, it forces you to understand what sine and cosine really are. Okay. So really spend the next week trying to remember this thing, and I'll post a filled out version of this that's typed rather than handwritten on Canvas if you'd like to have a better looking one to work with. All right.